Hi, for homework 9, question 7, we need to show that the random telegraph signal is a strict sense stationary process. Okay, let's start. So we need to prove it's a SSS. So what we want to prove, or what we want to show, is the probability of capital Tn equals, capital YTN equals YTN, capital YTN minus 1 equals YTN minus 1, and so on, to capital YT1 equals YT1. This probability should be equals to the probability of capital Y T n plus epsilon equals Y T n. Capital Y T n minus 1 plus epsilon equals Y T n minus 1, and so on. Capital Y T1 plus epsilon equals Y T1. This is what we want to show or prove. To prove this, we need to use some example to show this process of proof. First, let's see that the probability of capital Y Tn equals 1 based on capital Y Tn minus 1 equals 1, capital Y Tn minus 2 equals 1, and so on. Capital Y T1 minus equals 1. This probability should be equals to the probability of capital Y Tn equals 1 based on capital Y Tn minus 1 equals 1. And this should be equals to e to the power of lambda times Tn minus 1. And this times cosh Tn minus 1. For this equation, we can have this graph. I'll just simply draw a simple figure. Sorry. We can see that, for example, here is Tn minus 1, and here is Tn. Okay, so the probability of capital Y Tn equals 1, capital 1 Tn minus 1 equals 1, and so on, and capital Y T1 equals 1. This should be equals to the probability of capital Y Tn equals 1 based on capital Y Tn minus 1 equals 1, and so on, and capital Y T1 equals 1 times the probability of y t n minus 1 equals 1 based on capital Y t n minus 2 equals 1 and so on, and capital Y t1 equals 1, and times probability and so on, and times probability of capital Y t2 equals 1 based on capital Y t1 equals 1 times the probability of capital Y t1 equals 1. Yeah, and this should be equals to probability of capital Y t n equals 1 based on capital Y t n minus 1 equals 1 times probability of capital Y t n minus 1 equals 1 based on capital Y t n minus 2 equals 1, and so on, and the probability of Y t2 equals 1 based on Y t1 equals 1 times the probability of Y capital Y t1 equals 1, right? And as you can see here, this is a function of t1 minus t1 minus 1, and this is a function of t1 minus 1 and t1 minus 2, and this is a function of t2 minus t1. Yeah, maybe I'll write down. This is a function of tn minus 1, and so on. So the same for this 2, and this one is 1 over 2, 1/2, and this should be equals to e to the power of lambda tn minus 1 times cosh lambda tn minus 1, and so on, e to the power of minus lambda t2 minus t1 times cosh lambda t2 minus t1, and this is 1 over 2. And as you can see, this just only depends on ti minus 1, where I equals 2, 3, and so on to n. So we get this proved.